Just setting up a demonstration here of creep. Now steel creeps at around 350 degrees or above. This is electronic solder. Plumbing solder is probably the same. It creeps at room temperature. So what I'm demonstrating here is what happens when you put solder under a load. As you can see, it's quite springy. It's still quite springy. If I rock the car, this is on my motor car, by the way. If I rock the car, it's still springy. It still has its springiness. It hasn't melted. But you observe with the passing of time, the wire started to collapse. In fact, the wire in the foreground, I think, is already starting to go past the brickwork on the edge of the garage. I can see it starting to see it slowly giving way. Now, first time I did the experiment, I used a much shorter piece of wire, and it took an hour to collapse, which is around the same time it took the Twin Towers to go down. The wire at the back is a different grade of solder alloy, so even though it's a longer piece of wire, it's actually taking longer to tip over. But as the video runs on, you should see the wire at the back moving towards the brickwork over the garage door. That'll give you the indication that it's creeping. I once did this experiment with a piece of steel and a blowtorch. I put a load on it enough to bend it. I then removed 2/3 of that load, so there was only 1/3 of the load left. I aimed a blowtorch at the steel beam, and over the course of the next 20 minutes I could see it slowly starting to sag. In fact, if you look at steel frame buildings that have been caught in a fire, you can see that everything is sagged and drooped. Well, the steel hasn't actually melted. What's happened is it started to creep, and it starts to sag and droop in exactly the same way these pieces of solder are slowly sagging and drooping in front of us right now. The piece of solder in front of us is now gone to bent horizontal. The one at the back is still slowly on the move, but I can see it has passed in front of the garage brickwork. Interesting just to try this experiment with a short piece of wire and to come back to it 20 minutes later and find it still standing and think nothing is going to come of it, and then you come back next morning and find it's lying over. Because solder has a low melting point, it creeps at room temperature and demonstrates perfectly without the use of the blowtorch what steel does at elevated temperatures. Those slowly bending wires represent the sagging columns of the Twin Towers, which continued to sag until they'd sagged so much they were unable to take the weight, because it's a bit like standing with your knees bent. The more you bend your knees, the more difficult it is to stand. As the columns started to bend and warp, they could take less and less weight until they reached a tipping point and simply gave way. And once that happened, the buildings were on their way down. Yeah, I can see the wire that's not the wire in the foreground is now touching the top of the car. The wire in the background is now on its way to horizontal, has actually come towards the camera. The end of it is, I don't know if it's here, there's the end of it is there, I'm not touching it, just there. So it's just in the field of view of the camera, and it too is on the way down. And if we leave the camera running, you'll notice that even though that piece of wire is touching the top of the car, the middle of it will continue to sag and continue to droop as the effects of creep continue to affect it. Now that that piece of wire is horizontal, it's behaving like a horizontal girder in the building. That's affected by fire in that it'll continue to sag and droop under its weight. You might want to fast forward the video to see the whole thing speeded up.